Hackers exploit vulnerabilities to steal data, disrupt operations, and plant malware. A major example is the 2014 Sony Pictures hack, where North Korean attackers leaked confidential files. Investigators used packet captures and firewall log to trace malicious connections and identify the attackers. Malware spreads via phishing emails or infected software. The 2017 WannaCry attack infected over 230,000 systems worldwide. Investigators analyzed network traffic spikes, DNS logs, and phishing email records to track the malware's origin and contain the attack. Insider threats involve employees misusing access to leak sensitive data. In 2013, Edward Snowden used his NSA access to copy classified files. Network forensic evidence like the user activity logs, file access records, and share file monitoring helped track the breach. DDoS attacks flood networks with botnet-driven traffic. In 2016, a massive DDoS attack took down Twitter and Netflix by overwhelming the DYN DNS servers. Investigators used traffic flow data and source IP analysis to track the botnets and mitigate the attack. Intellectual property theft threatens business and governments. In 2019, a Tesla employee attempted to leak self-driving technology. Network forensics, including email logs, external storage monitoring, and remote access tracking, help prevent data loss.
Now let's see in a computer forensic project where we are analyze network activity evidence on a client computer. Now there are multiple types of evidence found on a client computer. First and foremost is internet browsing history. Internet browsing history is one of the richest source of evidence in internet browsing because browsers like Chrome and Firefox store URLs, search queries, and downloads in SQL-like database. Tools like Autopsy or Nearsoft's browsing history view can parse this data, revealing not just what was searched, but when and how often. Next is email communication. Email are a gold mine. Client-based email like Outlook, PST files, or webmail artifacts in browser cache can expose, send, or receive messages, attachments, and even deleted content. Tools like the Outlook Forensic Toolkit help recover and analyze these informations. The third one is network communications and logs. Network logs from Windows, event logs, or Linux, var log, track IP addresses, connection times, and protocols. For deeper analysis, Wireshark can reconstruct traffic showing what data was transferred and when. Next, we dive further into downloaded files. Downloaded files often linger in temp folders or the recycle bin. File carving tools like Foremost can recover deleted downloads, linking files to their source URLs, key for proving intent or knowledge. Next is social media activity. Social media activity isn't just in apps. Browser cache also store messages, posts, and media. Tools like Magnet Axiom specialize in reconstructing this activity, even from fragmented data. Next is VPN and proxy usage. Suspects using VPNs or proxies leave traces in config files and logs. Registry analysis on Windows or router logs can reveal attempts to mask their locations. And last but not least, for the type of evidence is malware and intrusion artifacts. Malware artifacts, unusual processes, persistent mechanism can be detected with memory analysis tools like Volatility. Sandboxing helps analyze suspicious files safely. Now, let's see into the guide for investigators to identify devices in home or business network that may contain valuable evidence. First is router and modems. Routers log every device that connected to the network, IPs, timestamps, and duration. Accessing these logs via the admin interface or tools like F- FTK Imager can map a suspect's activity timeline. Next is NAS devices. NAS devices is network attached storage, holds shared files, but also deletion logs. Forensic tools like Encase can recover files even after permanent deletion. Next is smartphones and tablets, where these hardwares contain call logs, GPS data, and app artifacts. Celebrite or Oxygen forensic tools extract these, often revealing communication missed on computers. Next, obviously the computers and laptops. Beyond hard drives, RAM captures active processes. Imaging tools like FTK Imager preserve volatile evidence before it is lost. Next is IoT devices like cameras, CCTV, or thermostats. These smart devices or thermostat log usage patterns. A suspect's smart thermostat might confirm their alibi or disprove it. Next is printers and scanners. Printers store copies of printed or scanned documents. Their internal memory can be a blind spot for suspects. Next is cloud storage devices. Cloud sync logs show file access times and shared links. APIs or tools like Cloud Analyzer extract this without tipping off the suspect. And last but not least, the external drives and USB devices. USB devices leave registry traces on Windows, showing when a drive was connected and what file were accessed. So to summarize, digital evidence is everywhere, from browser history to IoT devices. The key is knowing where to look and using the right tools, whether you are investigating fraud, cybercrime, or internal policy violations. This framework ensures you won't miss critical clues. Thank you. Pass on to the next one.
In digital forensic investigations, acquiring and analyzing system artifacts is crucial for uncovering evidence of user activity, system modifications, and potential security incidents. This report details the forensic imaging process using FTK Imager and the analysis of extracted registry files using RegRipper. The forensic imaging process was conducted on a Windows 10 Pro system with an Intel i5 processor, 12 gigabytes of RAM, and 101 gigabyte HDD. Using FTK Imager, an E01 format forensic image was created to maintain data integrity. Hash verification with MD5 and SHA-1 ensured the image remained unaltered. Key registry files extracted from the image included ntuser.dat, user preference, recent files and application usage, system configurations and startup settings, software installed applications and Windows version data, SAM, user account credential and login history, security policies and audit settings. RegRipper was used to extract relevant forensic artifacts from these files. For the ntuser.dat provided critical insights. Recent file access was documents, media files, and executable programs were logged. Installed applications were Microsoft Office, Adobe Acrobat, and various media players. Type URLs, no direct entries were found, suggesting browser history analysis may be required. User preference modifications included file type associations with Adobe Acrobat and Windows Media Player, compatibility mode settings for gaming software, running with elevated privileges. No highly suspicious malware indicators were found, but further analysis of startup programs and browser activity was recommended. Additional findings included system startup programs, OneDrive, and Discord were configured to launch at boot. Installed software history, Epic Games Launcher, NVIDIA drivers, and multiple reinstallation timestamps were detected. USB device history, further analysis of the USB store key may provide more details. The forensic analysis revealed user activity through recent file access, gaming software configured with elevated privileges, automatic startup applications such as OneDrive and Discord, no direct malware indicators, and additional system wide investigation is recommended.
Step 1 is check if the USB is recognized. First, we need to ensure that the USB device is detected. We use the following command. This lists all available storage device. If the USB is properly connected, you will see it listed as /dev/ SDB1 or similar identifier. Next step is verify if the USB is already mounted. Next, we check if the USB is already mounted by using the df command with a filter for our USB device. If the USB is mounted, the output will show the mount point as seen in our case. Step 3. List file in the USB drive. This will display all files, including important disk image, such as expert witness format, EWF file, commonly used in forensic investigation. Second is mount the EWF image for analysis. To analyze the .eon file, we first mount it using EWF mount. Next step is identify partition on the disk image. We now use fdisk to list partition details of the mounted image. Last step is verify partition detail using blkid. To determine the file system type, we use this command on the partition. In this case, no output was displayed, indicate that the partition may require deeper forensic analysis to determine their format and content. In this demonstration, we successfully identified and analyzed a USB device using the SANS SIFT workstation. We verified its mount status, listed file mounted and .eon image, and examine its partition. In the next step, we can use tools like AutoSpy or other forensic investigation tool.